Okay, Math 1100 students, we're going to learn here a new method for solving systems of equations, which you'll use quite a bit later in your Math 1630 course. This is solving systems of linear equations by a method called addition. So in this method, which is called addition or elimination, the addition method is based on the property of equality, the addition property of equality, which basically says that adding equal quantities to both sides of an equation results in an equivalent equation. That's basically another equation that has the same sets of solutions that the original equation did. It just looks different. So here we're going to solve the system of equations. And the basic idea here is that if we take the first equation, which is x minus 2y equals 8, and we add to that the second equation, which is negative x plus 5y equals negative 17. If we just simply add those two equations together, what happens is that x minus x will cancel out, and then negative 2y plus 5y will give us 3y, and 8 minus 17 will give us negative 9. And with the equation 3y equals negative 9, since we no longer have any x's, we can solve that for y by dividing both sides by 3. And negative 9 divided by 3 is, of course, negative 3. And then employing a part of our substitution method then, we can go back to the equation x minus 2y and substitute in negative 3 for the y. Which will then give us x. Negative 2 times negative 3 is plus 6 equals 8, which tells us that x is equal to 8 minus 6, which is 2. So that means the solution to our system is 2, negative 3. And as always, we should check that solution by substituting into our second equation, so if x is 2 minus 2 times negative 3, then 2 minus, oh sorry, forgot the 2 in front of it. Minus 2 times negative 3. And we want to know if that's equal to 8, so in fact, that is 2, negative 2 times negative 3 is plus 6, and 2 plus 6 does equal 8, which checks in our second equation. So there are some similarities between the addition method and the substitution method. So let's try another problem. Here we have the system 3x minus 2y equals 7 and 5x plus 4y equals 8. And unfortunately, if we simply add these two together, neither of our two variables drops out. However, if we were to take the first equation and we were to multiply that equation by 2, then what would happen is that we would have 2 times 3x, which is 6x, minus 2 times 2 is 4y, equals 2 times 7 is 14, and that is an equivalent equation because we've multiplied everything in the first equation by 2. So this equation is simply a multiple of the original equation. And then we'll proceed to add our second equation, 5x plus 4y equals 8. We'll add those two equations together. 6 plus 5 is 11x. Minus 4y plus 4y will again cancel each other out. And 14 plus 8 is equal to 22. And that then tells us that x is equal to 2. Then we will go back to the original set of equations. And I will use 5x plus 4y equals 8 with x is equal to 2. 5 times 2 plus 4y equals 8. 5 times 2 is 10 plus 4y equals 8. Subtract 10 from both sides. 4y equals 8 minus 10, which is negative 2, which tells us that y is equal to negative 2 over 4, which is negative 1/2. And again, we want to check that solution because our solution appears to be 2, negative 1/2. We want to check that solution into the first equation. So we have 3 times 2 minus 2 times negative 1/2. 3 times 2 is 6. And negative 2 times negative 1/2 is positive 1. And 6 plus 1 does in fact equal 7, and our solution checks. So here's our actual method for solving systems of equations. First, you're going to rewrite the equations in standard form. Thus far, we've had our equations already written in standard form. This is our standard form, which is ax plus by equals c, where a, b, and c are all real numbers. If necessary, we will multiply one or both of the equations by some non-zero number so that the coefficients of the chosen variable are opposites. Then we're going to add the equations, and that will result in an equation in one variable, which we can solve, and then we'll find the value of the second variable by substituting what we found in step 4 into either of the original equations. And then your last step, the very important step, is we always check the proposed solution in the original system. So let's try another example. Now I chose this example specifically because you're going to run into equations where you're going to have fractional coefficients, or you're going to have fractions in your equation. And one way that you can clear your equations of fractions and have equivalent systems is to multiply through by your least common denominator, which in the case of the first equation is 3. So 3 times every single term, x over 3, minus 3 times y equals 3 times 2. So this is essentially the exact same thing as what we did in the last example, just that we have a different goal here. We want to eliminate the fractions. And of course, since this is actually 3 over 1, then those 3's cancel, and we have left just x. And then x is minus 3y is equal to 3 times 2, which is 6. Now we have an equation that we don't have to deal with the fractions. And then we're going to do the same thing with the second equation, except the least common denominator in the second equation is 2. So we're going to multiply through this equation by 2, which gives us 2 times negative x over 2 plus 2 times 3y over 2 is equal to 2 times negative 3. And since this is essentially 2 over 1, then those 2's cancel, and this equation becomes negative x plus, these 2's also cancel, 3y equals negative 6. So this is our new system of equations. X minus 3y equals 6. Negative x plus 3y equals negative 6. And we will solve those by adding those two equations together. X minus 3y equals 6. Negative x plus 3y equals negative 6. And we see here that when we add these together, x minus x gives us 0. They cancel each other out. Negative 3y plus 3y also gives us 0 because they canceled each other out. But again, 6 minus 6 gives us 0, and 0 is in fact equal to 0, which we know from previous solution methods tells us that this is a true statement, but it works for all values of x and y, so there are infinite solutions. And that's because the lines, if you were to graph this system, are actually the same line. So continuing on, here we have a system that has decimals. You can also eliminate the decimals if you choose to do so by multiplying through by a number that will eliminate all the decimals. In this case, I'm going to use that method, and I'm going to multiply through by 10, so that I have whole number coefficients for x and y. And when I multiply through by 10, all that really does is move the decimal one place to the right. So this equation turns into 35x plus 25y is equal to 170. And the second equation changes to negative 15x minus 75y equals negative 330. Now, if we just add those two equations together, that doesn't help us much. However, since we know that 3 times 25 is 75, if we multiply the first equation by 3, we will get an equivalent equation that will cause the y's to drop out. So we will do that. 3 times 35 is 105 times x plus 3 times 25 is 75 times y is equal to 3 times 170 is 510. And then to that, we will simply add the second equation, which is negative 15x minus 75y equals negative 330. So we will add those together, and as expected, positive 75y and minus 75y will cancel out. And 105 minus 15 leaves us with 90x is equal to 510 minus 330 is 180. And then we'll divide both sides by 90 and get x is equal to 2. And now that we have x is equal to 2, we will return to one of the original equations. I'm going to choose the first one. 3.5 times 2 plus 2.5 times y is equal to 17. 3.5 times 2 is 7 plus 2.5y is equal to 17. And if I subtract 7 from both sides, I have 2.5 y equals 10. And 10 divided by 2.5 tells me that y is equal to 4. So my solution to this system is 2, 4. And you can check that in your second equation, but that answer is the correct answer. In the interest of time, I'm going to leave the check up to you this time. So in a similar fashion to what you found in the last section, you will use the addition method to combine two equations, which might lead you to results like 5 equals 5, which is always true, thus indicating there are infinitely many solutions. Or something like 0 equals 6, which of course is never true, indicating there are no solutions. because the equations represent parallel lines. So this concludes our lesson, and you are now prepared, hopefully, to do your homework for section 11.3.